tells us two terms in an arithmetic sequence. Term 4 is minus 4, term 7 is 23. And we want to find out what term 1 is. So if we show this as a visual, we have our sequences, 1, 2, 3. Term 4 is minus 4, then we don't know 5, we don't know 6, and then we know term 7 is 23. And we know that it is an arithmetic sequence, so that's telling us that the jump between the terms is always the same number. This question right now is very similar to the one we did with the license plates right at the beginning. You had one license plate, then you had two missing, and then you had a third license plate. Does it make sense that to go from term 4 to term 7, you're going to have to add whatever the common difference is, and I'll just use the letter D, you're going to have to add it 3 times. So now how do we set that up to figure this out? And we have a couple of different options. The option that we did, do you remember what we did when we did the license plates? We figure out what's the difference between these two, right? So one way that we could do this is find the difference. So if I go 23 minus a negative 4, which is going to be positive 27, right? And I find out that we've gone up 27 from negative 4 to 23. Then all I would need to do is divide by 3. How should we describe this? Because it's divide by 3 because there's been 3 D's, but if there was more spaces, you divide by a different number. Divide by the number of D's, the number of jumps. What do you think makes the most sense for you when writing it down? Number of jumps? And if I wanted to at this point, I could say I could fill in numbers. Negative 4 plus 9 would get me to 5. 5 plus 9 would get me to 14. Does 14 plus 9 get me to 23? Yes, it does. So I've sort of done a check right now to see this seems to be working. How would I find term 1? If I wanted to go backwards? What do you think this one's going to be? Negative 13. What did you do? Subtracted 9. If you did that again, subtracted 22. If you did that again, subtracted 9, negative 31. So that works as well. You could use your jumps and go backwards until you get to the point. Okay? A couple of things. Sometimes you may not want to use that. I could give you the same question, but instead of term 4 and term 7, right, I could have term 412 here and term 415. There would still be 3 jumps, it would still be 9, but it might be kind of annoying to go back 9 411 times to get to the beginning. So let's also look at this question, how we might solve this with formulas or with writing equations. So I love this. It's a great idea. This shows that you know the difference between these, how many jumps are in between. and get to solve it. If I wanted to write this with variables right away, does the following make sense? So I'm going to draw a line here. I'm going to switch colors, purple, and say, looking at what I've drawn, to go from negative 4 to 23, if I go negative 4 plus d 3 times, I should get to 23. Does that equation make sense? And now that we have this equation, we could solve for d. Notice when I add 4 to both sides, that gets my 27, just like we figured out the 27 wasn't the common difference. And when I divide to solve for d, I get 9 the same way that we got for 9 the other way. Do I have a preference between those two? No, they're both great. Okay, they both are built on the same idea. But one I used an equation that said if I start at negative 4, I'd have to add d 3 times to get to 23. Now, I know what d is. I know term 4, I know term 7. We could also use our formula to figure out what term 1 is. If I write out the formula is Tn T1 plus D n minus 1. I want to find term 1. So the question in the formula, in order to solve for something, since I want to find term 1, are there things that I know that I can put in for everything else? So in this case, I know D. D is 9. Do I know any terms? I know term 4. I know term 7. And in this case, it's not going to matter which one you choose. Which one do you want to choose, the 23 or the minus 4? 23 because it's positive? Okay. If you choose the 23, you're choosing term 7. So what am I going to put for n? 7 minus 1. Does that make sense what happened there? If you chose minus 4, you would have to use 4 for n. From here, this is 6 times 9, 54, subtract 54 on both sides, and we get term 1 is minus 31 as well. So 1, in this case, it was not much work to subtract 9 each time. Great idea. But you can see that if we started with term 412, you might not want to subtract 9 411 times. So our formula, if we plug in the things that we know, it provides us a way to solve for things as well. So both are very powerful. Okay, I'd like you to try a couple of these. So question 10 and question 13.